Hi students, in this video we will study about multiple access protocols. The multiple access protocols are performed by the lower layer or the sublayer of the data link layer known as multiple access control layer. And what is the problem of multiple access is when two or more nodes transmit at the same time, their frames will collide and the link bandwidth is wasted due to collision. And the solution for this problem is to coordinate the transmission between nodes. And these protocols for controlling the transmission or coordinating the transmission of the nodes are known as multiple access protocols, and this is the main activity of the MAC layer of the data link layer. Then various taxonomy of multiple access protocols are given in this figure. And there are mainly three different classifications. One is random access protocol, second is control access protocols, and third one is standardization. And the random access protocols and control access protocols are the protocols which are included in our syllabus. So we are not at all bothered about the channelization protocols. And each of the protocols in the random access as well as control access has to be studied in detail in the coming slides. First of all, what is random access protocols? Random access or contention method. In this method, no station is superior to another station and none is assigned control over another. No station permits or does not permit another station to send. Everyone are having the equal privilege to send or not sending the data. At each instance, a station that has data to send uses a procedure defined by the protocol to make a decision on whether to send or not send. The main protocols included in random access are Aloha. In Aloha, there are two different types of Aloha. One is pure Aloha and slotted Aloha. Then carrier sense multiple access, carrier sense multiple access with collision detection, and carrier sense multiple access with collision avoidance. And first Aloha protocol is pure Aloha protocol. In pure Aloha, all frames from any station are of fixed length and stations transmit at equal transmission time. Equal transmission time is allotted for every nodes. And if a station has some data, it can transmit at any time. It is not waiting for others to transmit, or it is not respecting others. Anybody can have data, they can transmit at the very same moment. After transmitting a frame, the sender waits for the acknowledgement for an amount of time, and this amount of time is calculated as a round trip time of the propagation delay, round trip propagation delay, that is the time to reach for a frame to its destination and its acknowledgement to be accepted. And these are the two transmissions for each frame. So 2 times the propagation delay is the time of wait after transmitting a frame, that is experimentally calculated value. And after sending, it will wait, and if acknowledgement is received within the waiting period, then sender assumes that the frame or the acknowledgement has been accepted there. If no acknowledgement is received, then the frame or acknowledgement is destroyed. That is what the assumption taken by the sender, and it resend the frame after a waiting time. If a station fails to receive an acknowledgement after repeated transmission, then it will give up the activity. And in pure Aloha, the channel utilization and channel efficiency is very less because the chance of collision is very high. So the percentage of channel utilization is 18%. What does it mean is, if we are sending 100 frames, then only 18 frames will be received successfully at the destination. Here in this figure, we can see that station 1, station 2, station 3 and station 4 are transmitting frames, and in the collision region, here multiple frames are sent by the multiple stations. Since the channel is shared, the frames are collided, and here also 2 frames are colliding. So this will waste the channel utilization, and these collide frames are to be resent again. This is how the algorithm, it is explained in the previous slide. The same thing is explained here as a flow diagram. You can either write it as an algorithm step by step, or you can represent like a flowchart like this. The protocol begin from the start, then K is set as 0. If a station has some data, it send the frame and wait for the acknowledgement, and the waiting time is 2 times the propagation time. And if the acknowledgement is received, then we can assume that the transmission is successful. If within that waiting period, if no acknowledgement is received, then K will be incremented, that is just for waiting and time to be increased. Then K is incremented and K is checked with the Kmax value. That is, Kmax is normally, it is a number taken as 15. That is, for sending a particular frame 15 times, the sender is trying to send it a frame without any collision. Inside the 15 number of chances, it may accepted by the receiver. Otherwise, it will abort. That is, after the 15 trials, it will be aborted. Then K is incremented by 1 and K is checked for the Kmax value. If the value of K is less than the Kmax value, that is number of attempts is less than 50, then choose a random number between 0 and 2 raised to K minus 1, and the propagation time is again calculated. This is what the new calculation TB. The TB is equal to R into TP or R into TFR. TP means propagation time, TFR means average transmission time for a frame. Any one of these two can be set as a value for TB. Then again the same procedure is repeated, and this will be continuously done for 15 times. If all the chances are failed, then it will abort the sending process. This is what the algorithm says. The extension of the pure Aloha is the slotted Aloha. Here separate slots are given, and every slots are of equal duration, and a station can send the frame at the beginning of a slot. So this will reduce the collision, and the bandwidth utilization will be better than the pure Aloha. But still we have a chance of collision because of the propagation delay. Here in this figure we can see that in two different areas there the collision is happening. Here one collision is happening, and in another slot also one collision is happening. If a collision is happened, the complete all the frames included during that slot will be destroyed. The next type of random access protocols are carrier sense multiple access. In the pure Aloha and slotted Aloha, there is no idea of sensing the channel, whether the channel is free or not. Whenever the sender is having some data, then At the very same moment, it will start transmission in case of pure aloha, and in slotted aloha, it will be send the frame at the beginning of a particular slot. Whereas in random access carrier sense multiplexes protocols, there is a concept of carrier sensing. Carrier means the transmission medium. Before sending the frames into the channel is sensed by the sender. And this will minimize the chance of collision and increase the performance. So, CSMA is the mechanism used in the current terminology for transmission of frames into the shared medium. If a station with a frame has to be sent, a second bullet, if a station has frames to be sent, it should sense the medium for the presence of another transmission carrier, another transmission before it starts its own transmission. So the idea can be concluded like this: sense before transmit. If a frame was sent by a station, all stations knows immediately, so they can wait before start sending. This can reduce the possibility of collision, but it cannot eliminate the collision. This can reduce, but you cannot eliminate the collision. The possibility of collision exists because of the propagation delay. So, in the slotted aloha and pure aloha and in CSMA, in all these cases, the possibility of collision is due to the propagation delay. So, what is the propagation delay? We can assume here that a station A, a station B, station C and station D are included in this figure. Station A is transmitting some frame. The transmission is started at time t1, but the frame reaches at the destination D after a particular time period. So, this is what the time known as propagation time. And this propagation time is a vulnerable time because there is a chance of collision when other stations also start to send within the same period of time. When the other senses a channel, if the channel is felt as busy, then the stations will revoke from transmitting the data. But it cannot always expect that while sensing the channel may be free, but after transmission started by another station, there may happen a collision due to the propagation delay. In CSMA, three different persistence methods are used. When the station is idle, when the channel is idle, what the station has to do? When the channel is busy, what the station has to do? For this, the persistent methods are devised. The persistent methods include one persistent method, non-persistence method and p-persistence method. And this figure shows the behavior of three persistence methods. In case of one persistence method, the station continuously sends the channel. If the channel is busy, it will continuously sense until it gets a time to transmit. That is, whenever the channel is felt as idle, then the station start to transmit the data. That is the behavior of one persistent. In case of non-persistence, initially it sends the channel, the station sends the channel if it is busy and it is not continuously continuously sensing just like the previous case. It will wait for a random amount of time and again it will sense the channel. Still it is busy, again wait the same amount of time or a period of time that may be equal or may not be equal, that doesn't matter. But The next sensing time, when the channel gets free, then it starts the transmission. That's the case of non-persistent. In case of p-persistence, the station continuously sends the channel just like the first case. Then when the channel gets free, it is not sending the very same moment. Instead of that, it will allow a time slot, a period of time again as a waiting time. Then again it sends the channel. Then still it is free. Then only it will send the data. In the first case, at the very same moment when the channel is idle, it starts sending. Here, even though the channel is free, it will wait a random amount of time or a given time slot, then again sends the channel, then only it transmits the data. That is the case of p-persistence. So the p-persistence take the advantage of both one persistent and non-persistent. The continuous sensing is the nature of first one persistent, and the waiting slot is the nature of second method, that is non-persistent. So the third one combines the advantage of the first and the second. In the first case, the station decides that the frame will reach the destination with 1% of probability. That means the probability value 1 means it is taking the assumption that is 100% guarantee that transmission will success. But in practical, it may not be like that. In non-persistence, here there is no probability chance, but it is assumed to be a better version than the one persistence. And in the last case, there is an assumption of p% of chance for reaching the frame successfully at the destination. The same thing is explained in sentences here. To avoid idle channel time, one persistent protocol is used. Whenever the channel is idle, it starts transmission. The same thing is explained algorithmically here. And the performance is that one persistent stations are selfish and they assume that the channel, if the channel is free, there will be a probability of 1 to reach the frame at the destination. In case of non-persistent, when a station having frames to send, it should sense the medium, and if the medium is idle, it start transmitting the data. But if the medium is busy, it will back off a random amount of time and repeat step number 1. The main difference is sensing is not continuously. Non-persistent stations are respecting others. That's why it is sensing with a time period. The performance, random delays will reduce the probability of collision. So the waiting delay will be random. Here the waiting delay is this much period, and here the waiting is more than the previous one. The bandwidth is wasted here. That is one drawback. Because of this, channel sensing is happening in a time duration. This much area, the channel was, even though the channel was free, it was not able to be utilized. So bandwidth utilization is poor in case of non-persistent than the previous one. So we are combining the advantage of the previous two persistent methods into the p-persistent. Here the transmission is happening with a probability of p, and waiting time 1 unit of time with the probability of 1 minus p. That is just a probability mathematics only. If the frame arrives with a p, then the chance of collision is 1 minus p. Then here the channel is sensed continuously, that is the behavior of the first one itself, and the time duration is fixed length time duration, and this will reduce the possibility of collision, and the channel utilization is also better than the non-persistent methods. The same three behavior are explained with the help of a flowchart. Here it is a one persistent method, here it is a non-persistent method, and here is the p-persistent method. In one persistent, continuously sends the channel. If it is busy, the same thing is active, continuously performed. Whenever it is idle, it will transmit the data. In case of non-persistent, it will wait a random delay of time if the channel is busy. Otherwise, if the channel is idle, then it will start transmission. Here, whenever the channel is idle, then it will send the data with a probability of p, and if the channel is busy, and it will back off, and same the channel is sensed after the t time slot, and the waiting time for the time slot is always greater than p, where p is a probability value, and this might be experimentally calculated. And next type of random access protocol is CSMA/CD, means carrier sense multiple access with collision detection. This is also an extension of the previous algorithm CSMA. And here we can see that the station A start its transmission at time t1, and at time t2, when the station C senses the channel was idle. So at time t2 it starts its transmission. The yellow lines are showing the transmission of station C, and blue lines are the transmission of station A. So after a period of time, due to the propagation delay, there happens a collision. Then once the collision is identified, then it can be detected by the sender. This is what the new concept in the CSMA/CD, collision is detected by the sender. Here at time t4, the collision is detected at the station A. So at time t3, the collision is detected at station C. So this collision detection happens at t3, and this collision detection happens at t4. Once the collision is detected, then the sender will no more sending the packet, or it will stop its transmission. Both the stations involved in the collision will stop its transmission. Here further we cannot see any frames from station A or from station C. This is what the idea of collision detection. Once the collision is detected, the frames will be automatically aborted by the sender itself. These ideas are not present in CSMA. These are the additional concepts added to normal CSMA. Here the CSMA/CD algorithm is explained with a flow diagram. The flowchart begins from here start, and K is set as 0. Since this is the extension of the previous CSMA, any one of the persistent methods of the CSMA can be performed here for sensing the channel. And if the channel is free, then transmission is performed. Then transmission is done or collision is detected. If the transmission is happened or transmission is completed or transmission is done or collision is detected, in both cases the S will be there and the path will be taken to this direction. And if no collision is detected or transmission is not completed, at that time the transmission and receival, this loop is continuously performed. Once this path is taken, there may be a chance of collision. If there is no collision, then the transmission is successful. If a collision is happened, this is what the main difference of CSMA/CD from the previous CSMA method. Here, once a collision is identified, the next duty is to send a jamming signal by the sender so that others can revoke from the transmission. Then K value is incremented. It was initially set as 0. K is incremented. This is for finding the number of chances of transmission. If it exceeds 15 times, then it will abort the transmission. If it is less than 15, then choose a random amount of time or the waiting time is computed. Then again the same procedure is repeated for sensing the channel, and this is continuously performed in the case of CSMA/CD. Then this figure is representing how the station is detecting a collision. The collision when happens, the energy level, actually the bits are voltage levels or energy levels. So while a collision occurs, the energy level will be double than the normal energy level. This is what the normal frame transmission energy level, and it will be doubled when occurs a collision. This is how the channel identifies the collision. The next main classification of multiple access protocol is controlled access protocols. In controlled access, the stations consult one another to find which station has the right to send. A station cannot send unless it has been authorized by other stations. So we discuss three popular controlled access methods. They are reservation, polling, and token passing. So the first method of control access type is the reservation access method. In a reservation method, a station needs to make a reservation before sending the data. The time is divided into various intervals, and in each interval the reservation frame precedes the data frames sent in the interval. Suppose if there are m stations in the system, there are exactly m reservation slots. So here we can see that 5 reservation slots are there, and the station 1, station 3 and station 4 are reserving the respective time slots of their transmission. At station 1, the slot 1 is reserved, station 3, slot 3 is reserved, and station 4, slot 4 is reserved. Then, when a station needs to send the data frame, then the station must make a reservation before sending the data, and at the reserved time the station can send the frame. Same thing is explained here in sentence. M slots will be there for m number of stations, and each station can make a reservation. They can send a frame at the time slot which it is booked by the device or the station. Then the stations must send their data during the time slot in the order of their booking. So after the transmission period, the next reservation interval begins. Since everyone agrees on who goes next, there will never be any collision. The next method of control access is polling, or it is also known as taking turn protocols. Here there will be a master device and all other stations are known as slaves. The master node primarily invites the slave node to transmit in turn, that is in the round robin fashion, that is one after another. So the round robin order is assigned by the master node. Primary device controls the link and the others are known as secondary devices. This is another term for master and slave, primary and secondary. And each node can transmit maximum frames in the given chance. Since this is a round robin, the time duration given for each of the station will be equal. So here one additional overhead happens is a polling or assigning each of the station an order for the transmission. This is known as the polling. So the polling will take some delay and it has to assign some nodes to deliver its packets or the frames. Then another drawback is if the master slave is happening some failure or hardware failure or some sort of failure, then the entire system will get into damage. So this is what the drawback of taking 10 protocols. Otherwise, this will be better than the this will be a better algorithm for taking without any collision. In case of polling, one master node is assigned the duty of selecting one of the secondary node. But here an extension of the polling is a selection procedure, and here the selection procedure, when a master device want to send something to a station B, here the one which is having some data is known as the primary station and the receiver is known as the secondary. So one among the secondary is selected by the primary, and if the station B is ready to send, then it will send an acknowledgement. Then the primary station can send the data. And if the primary station request is raising to station B, and if it is not ready at that time, then it can process a or send a signal negative acknowledgement. And at that time, it will send the another station for data transmission, and if it is free, then it can send the data. So as and when the station is having some data, it will act as a primary and others are acting as the secondary. Whereas in the previous case, the master station is assigned the duty of polling and it was a single point service, or the polling is happening at a single station. Here the drawback of the single point failure is eliminated. Then another taking turn protocol is known as token passing. Here we can see a green token. So it is represented in green, that's it. Nothing important for this color and all. The token is a particular pattern and the set of stations will be there. Whoever is having the token, they can transmit the data to the channel. So after the transmission of a particular station, the token will be delivered to the channel again. Then one of the stations which is having some data can grab the token from the channel. The token will be rounding around the channel, and it will be freely available and any one of the station can grab the token. And here the drawback is a new token creation and token communication, token passing, and to access the token. All these are making some sort of delay. And again, there will be only one token for the entire n number of nodes. So if the token is happen some failure, then it will damage the entire transmission. So the last two control access methods are commonly known as taking turn protocols, and totally there are three different control access protocols. One is reservation, and two taking turn protocols, and one is polling, and another is token passing.